In the previous video we have done series and parallel connection. Okay, but some sentences in the textbook, please you read it. Also you go through this 12.2. okay. Now this topic is not there, factors on which the resistance of a conductor depends, that is in the PDF. So right now we will not go through it. Now we will go for the next. Okay, this all previously it is to be learned, but now not there. On the base of that, questions are also gone. So one way you have got a less burden of electricity. This we have taken in the previous one. Okay, series connection, parallel connection. How much I have given you do. Okay, this is more in words. So what I am doing, you can write that also. Okay, this way, the same way I have done. Some sentences, the last sentence I took from textbook directly. Okay, and on the basis of sums are there, so sums video I will be making another one. This is the resistance in parallel. This way we have connected the bulbs in the parallel, and then we got the result. 1 by R1 is equal to 1 by R is equal to 1 by R1 plus 1 by R2. Okay, and on the base of this sums are there. Now, good topic, हीटिंग इफेक्ट ऑफ इलेक्ट्रिक करंट. हीटिंग इफेक्ट, इलेक्ट्रिक करंट से कौन सी चीज़ गर्म होती है? माइक्रोवेव है, इलेक्ट्रिक आयन है, गीज़र है, ओके, टोस्टर है, सैंडविच मशीन्स है. वी नो दैट अ बैटरी और अ सेल इज़ अ सोर्स ऑफ इलेक्ट्रिकल एनर्जी. द केमिकल रिएक्शन विद इन द सेल जनरेट्स द पोटेंशियल डिफरेंस between its two terminals that sets the electron in motion to flow the current through a resistor or a system of resistors connected to the battery. We have also seen in section 12.2, you can have a look, that to maintain the current, a source has to keep expanding its energy. Where does the energy go? A part of the source energy is maintaining the current may be consumed into useful work, like in rotating the blades of an electric fan. Rest of the source energy may be expended in the, see the spelling, take care of the spelling, this is not expanded, it is expended in heat, convert into heat, और वो lost हो रही है. To raise the temperature of gadget. कोई भी चीज़ हम गर्म करने, जैसे कि समझो कि बैटरी लगाई, ठीक है, you keep the phone in charge, then afterwards you will see phone is also hot, charger is also hot, that is a loss of energy. Where does this energy go? A part of the source energy is maintaining the current may be consumed into useful work, like in rotating. Okay, rest of the source energy may be expended to heat, to raise the temperature of gadget. We often observe that in our everyday life, for example, an electric fan becomes warm if used continuously for a longer time, etc. On the other hand, if the electric circuit is purely resistive, that is, a configuration of resistor only connected to a battery, the source energy continually gets dissipated entirely in the form of heat. This is known as heating effect of electric current. This effect is usually in devices such as electric heater, electric iron, etc. Consider a current I flow, these all formulae, flowing through a resistor of resistance R. The potential difference B V. Let T be the time during which a charge Q flows across. The work done in moving the charge Q through a potential difference V is VQ. Therefore, the source must supply energy equal to VQ in time T, hence the power. This only you should remember that Q is charge, I is current, V is voltage, T is time. Then you can write down these things. Hence, the power input in the circuit to the circuit by the source is P is equal to VQ by T, that is VI. On the energy or the energy supplied to the circuit by the source in time T is P into T, that is VIT. ये एक डेरिवेशन है, ठीक है. VIT का फॉर्मूला डालेंगे तो हमको मिलेगा हीट एनर्जी का फॉर्मूला. What happens to this energy expanded by the source? This energy get dissipated in the resistor as heat. Thus, for a steady current I, the amount of heat H produced in time T is H is equal to VIT. Because we know that, okay, applying Ohm's law, I will be getting H is equal to, make block this formula, H is equal to I square R T. This is known as Joule's law. Directly they can ask also explain Joule's law. So that topic directly you have to do. The law implies that heat produces I square RT. So it depends on square. From the formula you can make up the curve. Heat energy is directly proportional. 3 चीज़ें आ जाएंगी, ठीक है. Directly proportional to the square of the current, directly proportional to the resistance, and directly proportional to the time. Okay. So that only written down. Given resistance. Okay. Now produce in a resistor. Heat produced in the resistors is directly proportional to the square of current for a given resistance. Second, directly proportional to the resistance for a given current. And third, directly proportional to the time for which the current flows through the resistor. In practical situation, in which the time for which the current practical situation when an electric appliance is connected to a known voltage source, equation 12.21, is used after calculating the current through it using the relation VI is equal to V by R. Okay. On the base of that, sums are also there. So as in text we shall see it afterwards. Now practical application of heating effect of electric current. The generation of heat in a conductor is an inevitable consequence of electric current. In many cases it is undesirable as it converts useful electrical energy into heat. In electric circuit, the unavoidable heating can increase the temperature of the component and after they change their properties. However, heating effect of electric current has many useful applications. The electric laundry iron, electric toaster, electric oven, electric kettle, electric heater are some of the familiar devices based on Joule's heating. The electric heating is also used to produce light, as in an electric bulb. Here, the filament must retain as much of the heat generated as is possible, so that it gets very hot and emits light. It must not melt at such high temperature. A strong metal with high melting point such as tungsten, please underline from here or make bracket, a strong metal with a high melting point. And this is 1 mark question. Melting point 3380 degrees centigrade is used for making bulb filament. The filament should be thermally isolated as much as possible using insulating support, etc. The bulbs are usually filled with chemically inactive nitrogen and argon gases. Please underline this all. To prolong the life of filament, most of the power consumed by the filament appears as heat, but a small part of it is in the form of light radiated. Another common application of Joule's heating is the fuse used in electric circuits. It protects circuits. If they say light short not on fuse, so you can write from here. It protects circuits and appliances by stopping the flow of any unduly high electric current. करंट अगर हाई हो जाता है तो वो खुद ही खुद बंद हो जाता है ताकि दूसरे अप्लायंसेस घर के बिगड़े ना. The fuse is placed in series. Please underline. I have told you when I was explaining series. With the device, it consists of a piece of wire made of a metal or an alloy of appropriate melting point, for example aluminium, copper, iron, lead, etc. If a current larger than specified value flows through the circuit, current अगर बढ़ जाता है तो वो वायर मेल्ट हो जाता है and it is disconnected. The temperature of fuse wire increases. This melts the fuse wire and breaks the circuit. The fuse is usually encased under एक setting set होता है in a cartridge of porcelain or similar material with metal end. The fuse used for domestic purposes are rated as 1 ampere, 2 ampere, 3 ampere, 5 ampere, 10 ampere, etc. For an electric iron which consumes, please underline, 1 kilowatt electric power when operated at 220 voltage, a current of 1000 by 220 ampere, that is 4.554 ampere, will flow in the circuit. In this case, a 5 ampere fuse must be used. तो जो अप्लायंस है उसके अगर हाई फ्यूज है, हाई रेटेड अप्लायंसेस है, दैट विल बी कनेक्टेड विद द सेपरेट फ्यूज. नाउ सी दिस टॉपिक इज out. Okay, so we are not going to do this topic also. The sums are also gone of this topic. So this was the last. You can have a look on this what you have learned. Okay, and what you have learned, you have to read of all the chapters. Here our chapter reading and our first semester course is over. And one good thing I tell you, from this chapter I am going to ask only in text. I am not asking anything from exercise. I will be asking something, but I will tell you the last question. Okay, the last question, which is the reasons. Okay, that much only. Sums are there, so I am not going to ask any sum from exercise, but in text I will be asking, and I will make video for the in text. Okay, so one less burden. There are no sums from exercise for semester 1 exam, but the last question number 18 is there. I think reasons are there, so that and all. Okay, I will tell you. See, these all are sums. Okay, these I am not going to do, but only I will be asking this question number 18 in exams. Okay, these answers I will be giving you. Okay, so you have to learn this question answer and all exam, because when school reopens, that time I will be taking all the sums. Okay, then you will be clear. Okay, so bye bye.